So this talk was given at SIGMOD 2016. It was done when I worked for Hewlett-Packard Labs. I am currently employed at General Electric Research. The work was joint work with Victor Gal from Technion, my colleagues at HPE, Omer and Ruth, and Alexander Avram from Yad Vashem was our historical expert. So let me give you the gist. Yad Vashem, I guess most of you know, but maybe you don't know that they have about a petabyte of data, lots of data. And that data is digitized documents and all of their metadata. Now, Yad Vashem's overreaching goal is to make this data accessible to as many people and researchers as possible, since in addition to being a museum, they are also a research institute. Now, the major obstacle for that is that this data has been collected by archivists. And archivists organize everything by collection and record ID, and people don't search like that. What interests people is other people and families and communities. So what we try to do in this project is to organize, closer, okay, to the left. Organize everything by entities. And I'm going to show most of the examples where the entity is a person, but you can get the general idea. Entity can be a community. And now the general computer science problem is called entity resolution, so we're going to talk a little bit about that. I'm going to show you why entity resolution is important for Yad Vashem. What we did, which is, in 4 words, use MFI blocks and alternating decision trees, and show some results if time permits. So every good story starts with a picture, and in my case, it was the picture in the middle. I looked over thousands of pictures and documents during the process of this project, but this picture stood out because at the time I was working on that project, I had one of those. I have one of those small little kids, 1-year-old, smiley, and that kid is named Massimo. And the picture was titled Guido and Massimo Fua in 1944. So first of all, it was my feeling that that kid was named Massimo, but he could have been named Guido. What we also know is there are 2 victim reports, which is things that people filled out about people that died in the Holocaust, and that were titled Guido Fua. And there's also a story about a person that saved a child named Massimo by hiding him from the Nazis, and she was from Italy, from a village named Corogna. Now, if we could automatically construct some type of a knowledge graph from all of these documents and sources, it would look something like this. So there was a person named Guido. He married Elena in 1942. They were both from Turin originally. They moved to Corogna in 1943, where they had a son named Massimo. And they eventually ran to hide in Canicio, where they were caught by the Nazis. Somehow they smuggled Massimo to be hidden by Clotilde in Corogna. And then they were deported to Auschwitz, where sadly Guido died in 1945. And the rest we don't know by these sources, but since Massimo eventually survived, grew up and became an historian and wrote a book, then we also know that he eventually reunited with his mother and, as I said, became an historian. So what we'd like to do is like to be able to tell the story for every person, family, and community that we have in Yad Vashem's database without requiring an historian to go over all of the details, collecting them together and making a coherent story. No, the problem is that the Yad Vashem names database is organized by victim report. So the central entity is a victim report, and you have maybe the victim's name, mother's name, father's name, and so on. And the distribution is not uniform. For some people we have the profession, for most we don't. So the general problem is called entity resolution. It was early years based upon the problem of merging 2 banks and finding the bank accounts for 2 people and merging them together when the people don't have a national ID or something to identify them uniquely. The problem is that doing this by pairwise comparison of every record to every other record just doesn't scale well and is not feasible using today's technology. So the usual solution would be to do blocking. Blocking is a form of clustering. You take the records, you collect blocks. Each block contains all of the candidates that you think, well, if anything matches anything else, it'll be in this block. And then you only have to do the pairwise comparison within the block that you chose. That reduces drastically the number of pairwise comparisons you need to do. And then you can do other stuff. If you have classification, then you can put everything in a deterministic database where you say, well, this is a single record, and all of the features collected from all of the records I found are merged into a single line. But if you don't, you can leave it as a probabilistic database, say, I have with some reason of certainty knowledge about that person's birthplace or permanent residency and so on. So these are the two directions, but in any case, we have to do some type of pairwise comparison. So our blocking algorithm was devised by Batya Koenig and Avigdor Gal. It's a very nice algorithm. I urge you to read about it. But what is most unique about this algorithm and what we liked about it was that the key that defines the group of records that are to be compared was different by group. So we don't group all the records by last name, but rather we try to find which is the best group of items that constitute good clusters. So the clusters are grouped by different keys, allowing the data to decide its own grouping, which is a nice feature of the algorithm. Details I'll skip. Now, after we had the blocks, we ran pairwise comparison using and iteratively improving similarity features. The way we improved them is we gave 10,000 records we took from Italy, and we started classifying them, started doing pairwise comparisons, and then giving them to be classified, if they're a match or a non-match, by the Yad Vashem research experts, using an application and so on. Eventually, after 3 rounds, we had 12,000 tagged pairs, match, non-match, maybe a match, and so on. And we could compare that to the similarity feature, and we saw that we had good correlation, so we decided to go forward. Now, as I said, sometimes we would like to perform classification so that we have a single source of truth. To do that classification, we needed a classification algorithm. Now, the problem is that we needed a classification algorithm that can handle missing features. So not all the records have all of the features, so you can't use classic decision trees. We used an algorithm called alternating decision trees. As you can see, results were great, actually amazing. And I actually have to attribute the good results to the very good work that Yad Vashem did to create equivalence classes. So according to Yad Vashem, there are 4,000 ways to say Avram, and they have recorded all of those ways. So Avram, Avreimele, Avrum, and all of that, 4,000 ways to say Avram, are in one equivalence class, and they've done that for every name of a person or a place in the Jewish world. Finally, the combination of the workflow looks something like this. We perform blocking using MFI blocks and then alternative decision tree classification. And the whole pipeline gave this results, which look very poor. But the problem is that we didn't have the perfect golden standard because we couldn't give 10,000 square matched pairs to our research experts at Yad Vashem because they would kick us out of the door. So instead, we did iterative. So what we found out is that if we take the false positives from these experiments and we give them back to the experts, we get 96% precision and recall. So what we're guessing is that we still have lots of matches that we just haven't classified as matches in the results. The results are probably better than we see. Finally, I want to say something about false positives. This is a result from our pipeline. As you can see, it's a false positive. Obviously, these 3 different records are not the same person. Do you agree? But they are a family. So if my entity is not a person but a family, this is a great result. Because I found the family of family Capeluto, the mother is Zimbul, and the first person I was looking for, Elsa, is this girl, and this is Julia. Missing is Alberto, which was born 1 year after this picture. So it really depends on what you're looking for, which brings us to the conclusions. This is only the beginning. Entity resolution used to be a database thing for banks and financial institutions. But in a world where we have lots of sources, millions of sources, not millions of records, but millions of sources, and each of these sources are generating millions of pieces of data, then a multi-source uncertain entity resolution is the new norm. We should look into what are the entities we're trying to resolve. It's not always people. Sometimes families, sometimes it's communities, sometimes it's online communities. And so the questions kind of change. Now, when the question changes, the tools change, and we saw that MFI Blocks is a nice tool to start with. Of course, we hope to try different tools in the future. not at HB Labs anymore, but hopefully Technion is picking this up, and if you want to talk to me about this research, I can still point you to the people that are continuing it. Thank you.